Hello everybody, welcome to my cosmic calendar. As a brief introduction, the reason we do this giant cosmic calendar here is because when we're discussing the big time scale within the class concerning the history of Earth events, it's actually very, very big, a lot bigger than you might initially expect. So I'll put up a visual timeline here, I'll insert it in the video. But if you see, if I just make a basic timeline and I try to include all of the events in Earth's history, it gets very, very messy very quickly, especially...
Alrighty, so I was having some issues with the video editing software. It wouldn't let me actually include an image. It just kept giving me an error, and I was too deep with the other software, or with my other footage and film to kind of backtrack. So instead of an image, I'm just honestly recording. I found this workaround. I'll just record my screen. It seems to take phone videos no problem. But this is the timeline that I'm talking about here, and as you can see, I've got the first of each month highlighted in those green. Everything's color-coded, and the blue ones are when Earth hits 1 and 2, 3, and 4 billion years old. And everything else is the color-coded events. And like I was talking about before, you can see towards the end, everything is sort of happening all at the same time, it looks like, even though there's large amounts of time passing. So yeah. And then also want to finish with, this is Philippi Park. This is in Florida. And I just did this on a field out here. Field was slightly over 100 meters. But yeah.
As you see towards the end of the timeline, where I can't even really fit in the text for the events because everything is so smushed together. So in order to sort of convey that grand time scale and put it into more easier to understand perspectives, what we do here is I've made a 100-meter cosmic calendar. If you want to just pan really quick, just show one side, and then just pan it back to the other one. And then there's the end over there, that's the end. And as you can see towards the end there, we have a lot more posters, and they're bunched quite closely together. And that's, you know, taking into account the fact that this is a 100-meter cosmic calendar, and we're still getting quite bunched up at the end there, so it puts it into perspective. But alrighty, hello everyone. So these are the materials I used to construct my cosmic calendar and the poster boards. So it was quite simple. Just started with these popsicle sticks. I picked these up at Michael's. Actually, I picked everything up at Michael's. But 2 popsicle sticks, construction paper. I would write down, you know, the title of the event, the day it was on the calendar, how far into the 100 meters we were, and then I just left a million years ago just to kind of give some context. And then I have a roll of tape here that we used and 1 marker, and that was all I used actually. So I would just take the back of this, take my 2 popsicle sticks, kind of set them on the back there, and then I would just tape it across, and then that would actually allow me to spike it into the ground. And that's how I have my standalone poster boards. So yeah. Hello everyone, just wanted to make a quick addition to the introduction here. How I measured out the signpost was I measured out a 1 meter stride, and then practiced doing the stride a few times until I was like comfortable consistently doing it. And then that's what I used to measure out the meters. I just took that stride. And then it was my mother who was helping me film. She was behind the camera. Alrighty, hello everyone. We're at the start of the cosmic calendar here. So first event is, we got January 1st, that's just signifying the start of the calendar, so it's the first day of our first month. And obviously in the history of Earth, that starts with the formation of Earth. So we're at 0 meters out of 100, and this is the first day. So then we'll continue on down. And our next event is going to be the formation of the moon. This was 4 meters in, we're at January 17th now. And the formation of the moon came about from when something collided with Earth, and it was actually part of the fragmentation that shot off of Earth, which is why we can see materials from the Earth's crust that are present in the moon. And then we'll come to the next one. So this is where Earth's crust starts to solidify. Alrighty, so the next event up is the crust begins to solidify. This is Earth's crust. Before it was completely molten, and here it starts to solidify. This is January 25th on our calendar, and we're now 7 meters in. Alright, so as we go to the next one, we're going to hit February 1st, so we are now 1 full month into the calendar. and this is 8 meters, so just 1 more meter from the crust solidifying. And here is when we have impacts deliver simple organics. Now this is one I want to draw highlight to, is one of my emphasized events. How I would give a good analogy for this is, I think of it like a restaurant receiving a food delivery. The things that come on the food delivery truck are, like spices, raw meat, utensils, building pieces that, make the meal. When you're coming to a restaurant and you buy a meal, these are kind of like the building blocks for that meal, in a sense. So these are like the building blocks for the life that will later on develop in Earth. And so a lot of those came from this impact that delivered those initial simple organics. And that is January 29th, 8 meters. So our next event is going to be the rains filling the oceans, and this is 9 meters in, just one more. And this is the second event I'm going to highlight, because as the crust begins solidifying and it begins drying out and it's no longer molten, how I like to explain it is the Earth sort of is like a dry, crusty sponge. So as rain starts to pour onto that sponge, we get a lot of the lower basins and the cracks start to fill up, start to become filled with water. And eventually, over time, those sort of craters from impacts and the dry crust ridges and the lower basins all start to completely fill up, and we actually start to get oceans on our planet. And again, that is February 2nd, 9 meters in. Alrighty. So to also answer one of our first of the 9 questions, what do I think was the most important event on the cosmic calendar between January and February? And my choice, even though I already expanded upon it, is actually the rain filling the oceans. I personally think it's the most important because this is really like one of the foundational steps to life developing on Earth, especially because we didn't have an ozone layer yet. And so having an ocean, especially like a deep one, is kind of what gave some sort of protection from that UV radiation from the sun that allowed life to initially develop underwater. And so I would say this is the most important one from January and February. So my first extra event that I included, one of the 5, is going to be Earth rotates in 10 hours. This is February 10th. We're at 11 meters in, so just over a tenth of the calendar. So back near the initial formation of Earth, its rotation was actually a lot quicker, which means the days were a lot shorter. So right now, a day on Earth would only be about 10 hours. The reason that Earth's rotation has slowed, as in like today we have 24-hour days or close to, is 2 main reasons. The first is the moon actually pulls and creates tidal forces on our oceans, and those actually create drag on the planet, which slows down the rotation, essentially just pulls on the planet a little bit. And the second reason is actually the ice caps, or the loss of ice over time on Earth, which sends more water mass to the equator, which is the middle of the planet, and in turn makes it rotate just a little bit slower. But we'll continue on, and we'll come to our next event here, which is the oldest known rock that we've discovered. There are plenty of different ways to test the age of rocks, a lot of which is called, it's like carbon dating, where we can use like the half-life of carbon and see how much residual carbon is left in an object and sort of date how old it is. But this is February 15th, 12 meters, and we'll continue. Next one is our heavy bombardment, or heavy bombardment ends. This is the period once all of the, we've had a lot of impacts hitting the Earth, a lot of comets and asteroids, and this is when that initial period ends. This is the February 22nd, 14 meters into the calendar. And we continue on. We're going to hit the first day of March. So we're now 2 full months into the calendar, 16 meters. And at about the same time, we have our earliest evidence of life. March 2nd, technically one day after, but about the same time at 16 meters. But the earliest evidence of life that we have that's dated this old. Alright, so we'll head back to our first birthday, so to speak. So now, March 21st, 22 meters in, Earth is now 1 billion years old. So if you think about that, we're not even a quarter way through the cosmic calendar, and 1 billion years has already passed. And if you look back, you can see that on the grand scheme, not really much has happened at all. Especially when we compare it towards the end of the cosmic calendar down there, where we have a lot more events and they're all bunched together. But here I am, I'm taking 4 meter, 3 meter steps between each event, and that's just to show you kind of how much time passes between a lot of these things that we're talking about. So another included event that's about the same time that I included extra is the supercontinent of Albero forming. The reason I included this one is because it's not 100% fact, but it's strongly supported by evidence. There are arguments for and against it, but it is our first, or supposedly Earth's first supercontinent. So I thought that was pretty cool. That's why I included that. And we're at 22 meters again, March 21st. Alrighty, so back to the next event. We're now at March 29th, so almost 3 full months in, 24 meters, so about 1/4. And these are some of the oldest fossils that we have dated. So a lot of the oldest fossils are actually single-celled organisms. So these are a lot of the first organisms that were on the Earth at the time, which is why a lot of the oldest fossils are single-celled organisms. Single-celled organisms don't have a nucleus. They're prokaryotes. So basically means the information, their DNA, so to speak, is kind of just loosely floating around. They're not really complex organisms. So to answer our second question of the 9, it's talking about how oceans and water on Mars would have disappeared 3.5 billion years ago. And using a comparison of Earth on our cosmic calendar, what would we have seen for the types of life there? So what we would have seen is probably just single-celled organisms, simple microbes. As you can see, 3.5 billion years ago, that's what we had here. But yeah, so Mars likely would have just had very simple single-celled organisms. But we'll move up to the next one, and this is where we're going to hit April 1st. So now officially 1/4 of the way through the cosmic calendar, 25 meters. And then so we're going to take a big leap, and as you can see here, on the grand scheme, there's really not much going on. I mean, I'm traveling a full month, a full 1/12 of the entire Earth's history, and nothing has happened at all. So we're at May 1st, 33 meters. And so the next actual event happens at 35 meters here. And this is our oldest record of a magnetic field. We're now at May 8th, so about 4 full months. Next one we have here is going to be another one of my included events. This is 3 out of 5. This is just showing the Earth's rotation. I kind of wanted to show how the Earth's rotation slowed throughout the timeline and at what points those were going to be at. So May 24th, 2,800 million years ago, the Earth's rotation slows to 15 hours. So if you actually think about that, that's a 50% reduction in speed. And we're not even halfway through the calendar. Alrighty, and moving on, we come to June 1st. So we're at 41 meters now. We're approaching halfway through the calendar. And this is where we actually start to see our first eukaryotes form. So eukaryotes versus prokaryotes, just a little bit of information. They just simply have a nucleus, which means that all of their genetic information is actually bound inside of a nucleus. It's not just freely floating around within the organism. But again, on the grand scheme, they're actually quite old. So that's 2,700 million years ago, so 2.7 billion years ago. But again, on the grand scheme, we're not even halfway through the calendar yet. So on to the next one. This is where we're going to hit our next birthday. So Earth is now 2 billion years old. So 2 billion entire years, and we're not halfway through the calendar yet. 43 meters, June 9th. And we'll pan back through one more time. So as you can see, 2 billion years, and probably only I'd say maybe 10 to 13 actual events, not including, you know, like June 1st, February 1st, that kind of thing. So it just kind of shows like the time scale we're talking about here. You know, yeah, Earth is really old, but it's not just really old, it's extremely old. And a lot of these things happened an extremely long time ago. And a lot. Alrighty, so as we approach the next event here, this is another one I want to bring emphasis to. So this is when the atmospheric oxygen level increases to 1 to 2%. June 17th, we're at 46 meters, so just about halfway there. The way I like to explain this as an analogy is I kind of like to think is the atmosphere is kind of like a party, like the atmosphere at a party. Initially, you know, as we're waiting for all of the guests to arrive, everything's kind of awkward. It's sort of still, you know, not much is really going on. So we have things like carbon dioxide, methane, and nitrogen. Those are your early guests. And eventually, things like bacteria and algae start to show up at the party. And with them, they bring their instruments and they decide they're going to start playing some music. And so their output at the party is oxygen. Those bacteria and algae, they produce oxygen. So as they start playing and the other people at the party start to join in, the atmosphere of the party starts to liven up. And that's where you see the oxygen start to come in. So it's a slow process. It doesn't happen immediately, you know. People start joining in, they start karaokeing, that kind of thing. But eventually, we start to get a little bit of oxygen in there, it becomes a little lively, and we start to have activity within the party. So we'll move on to the next one. Alrighty, so our next event here, the oldest evidence of a snowball Earth. So we have this dated about 2,400 million years ago, so on our cosmic calendar, June 25th, 48 meters. Still haven't approached halfway yet, but we're getting there. So as we move on to the next one, we're gonna hit July 1st, 49 meters, but you know, in terms of the days or the months of the year, halfway. So we are now halfway through the cosmic calendar. If you wanna just pan back to the start there, just again to put in perspective just how grand the time scale is. You know, events starting all the way back there and continuing all the way out there. So all of these things take an extremely long amount of time between each event that happens. So we'll continue down, and you can see from July 1st on our calendar all the way to August 1st. So another 10 meters, nothing happens. And if you think about that 10 meters, that's a tenth of my calendar. So in just this section, there's a tenth of my calendar where absolutely nothing happens, at least significant. And as we come to the next one, we're going to hit our next birthday, Earth being 3 billion years old at 65 meters, August 27th. And now we're starting to get into sort of the latter half of the cosmic calendar here. But again, kind of another big gap, I would say. All the way up to the September 1st, 67 meters. And we're going to keep going. We have October 1st, 75 meters. Again, we're still over 1 billion years ago. So the last quarter of my cosmic calendar, which is what you see right there, that's a whole 1 billion years right there. And even scaling it out to something this large, everything is still so bunched together. So as we get to our next real event, which is multicellular life emerging, we're at 80 meters now, October 22nd. So if you compare that to where we just were at 49, I just went about 30 meters and nothing really happened except Earth turning, 3 billion years old. So that's almost a third of that cosmic calendar. Kind of empty, at least for really, really significant events. And that's kind of how the time scale works. There's so much time that has passed that a lot of the time between these events, an extraordinary amount of time passes. So this is the multicellular life. So we're kind of now getting beyond super simple organisms like single-celled eukaryotes and prokaryotes. The first multicellular life that we would have seen would have been something like sponges. So those would have been like the first multicellular organisms we would have found. But we'll go ahead. And This event also is going to answer our third question of the 9, which is, when did multicellular life emerge on Earth? Well, it emerged 900 million years ago, and on October 22nd on my cosmic calendar. Alrighty, so answering question number 4 of 9, it's asking if the oceans on Venus evaporated 500 million to 1 billion years ago, and life was emerging at the same sort of trajectory as Earth, and we're using it as a comparison, what kind of life would we have seen? So to answer this question, I looked up how old Venus was, and it's 4.5 billion years. So if it's 4.5 billion years, and the water evaporated 500 million to 1 billion years ago, that means Venus had 3.5 to 4 billion years of development and activity. So if I'm using Earth as a comparison, I'm going to come look at 3.5 to 4 billion years, and I'm going to see what we have going on for life. And so Earth is 4 billion years, starts right here. It's this blue sign. And you'll see that the 3 billion years is that other blue sign right there. And about, a little more than halfway, and ultimately the only life event I have happening between these two markers is, again, multicellular life. So to answer, Venus likely would have had at least simple sponges and simple forms of multicellular life emerging. And move on. So this is November 1st. We're now 83 meters in, so we're at the last fifth of our calendar. And we're gonna hit number 4 out of 5 for my extra included events. And this is just gonna be Earth is now rotating in 20 hours. Really not much to add. It's the same two forces, ice melting and redistributing the mass of the water, as well as the moon pulling on the Earth's oceans, creating tidal forces that pulls on the planet and slows it down. Technically, today, most of our days aren't actually 24 hours. They're usually a little bit under. We have had times in the past where we've measured a day and it has gone 24 hours, but we're still actually not quite at what would the next increment be, would be 25 hours. We're still not even there. And this was, if you look, 750 million years ago. So we'll move on to the next one. Alrighty, so we're zooming here. This is gonna be the last snowball Earth that we think ever happened. As you can see on our calendar, it'd be November 10th, 86 meters. So we're still dealing with an extraordinary amount of time, 650 million years ago, so over 500 million. But this was the last time that the Earth was completely covered in ice. And we'll move on to the next one here, which is gonna be, alrighty, so resuming here, we have our next birthday. Earth is gonna hit 4 billion years old. And on our calendar, we're at November 14th. This is 87 meters, so we're approaching the last 10th, but we're not quite there yet. And at the same time is when I have my 5th extra included event here. And this is gonna be when the ozone layer actually sets into place. And I think this one is significant because essentially the ozone layer on Earth is what allowed life to move from just residing in the ocean to actually being able to traverse land, or start colonizing land, because the ozone layer is what protects us from the sun's harmful UV radiation. So we'll continue here. And next is a pretty big one as well. This is going to be the Cambrian explosion of life. So November 19th, 88 meters. This is when all sorts of multicellular life started to take place. We're not just in the ocean anymore, we're on land. So we're getting, like the early starts, not quite there yet, but the early start to things like mammals and dinosaurs. But I would say more complex multicellular organisms, not just simple sponges yet, but not fully blown, mammals walking around on all fours. And then just shortly after that, we have our first fish, and this is where it kind of gets interesting. So November 24th on the calendar, but as you can see, 89 meters, but I've also started including the centimeters here. So as we start getting a lot more bunched up towards the last 10th year of the calendar, it's not enough to just say 90 meters. You'll start to see on the future things, I might have 3 posters at 90 meters. So to better show the timeline of events, we start to include the centimeters as well. So it just starts here and then it continues after. So we'll move to the next one. And this is going to be our first mass extinction. So this is the end of the Ordovician mass extinction, November 27th on the calendar. And this is where we officially hit the last 10th of the cosmic calendar. So as you can see, we're at 90 meters, 43 centimeters. And right behind that, we start to see arthropods on land. So this is, as you can see, it's 87 versus 43. So I'm, about half a meter away. But that's why I started including the centimeters, because these are both at 90 meters. And again, it just kind of shows the time scale. I'm separating these by half a meter, and in reality, they happen, 20 million years apart. So I'm representing 20 million years, which is a small space here. So again, it just shows how massive the timeline of events is that we're talking about. But continuing on, this is atmospheric oxygen, just reaches the present level, just showing that oxygen filling our atmosphere from when I talked about 1 to 2% near the beginning, middle of the calendar. It is a slow process, and like I said, we're just now reaching the present level, which I believe is 10%. And that's 91 meters, 30 centimeters, November 30th. So right at the end of the second to last month is when our atmosphere actually reached the oxygen levels that we know of today. Alrighty, so we're resuming here. The start of our last month, so we're at December 1st now, final home stretch. I see 91 meters, 63 centimeters, so on the last 10th of the calendar. And the event here is we have our first vertebrates on land, 91 meters, 85 centimeters, so a little bit after. The first vertebrates on land would have been like amphibians. Basically, how I said before, that the ozone layer allowed life to move from the ocean to the land. So if you think about it, it kind of makes sense that the first organisms to be on land would be amphibians, ones that can live on land and water. And the next one that happens at about the same time, but is the late Devonian mass extinction. So this is our second mass extinction here. Same exact date, December 2nd, the same point, 85 centimeters on the 91 meters. And then moving back, you'll see we have our first seed that plants. So now we're starting to see like the progression of life on land, rather than just like mammals moving from the ocean to the land. We actually start to see like complex processes start to happen. And this is December 3rd. So on our calendar, only like 1 day after the mass extinction and vertebrates first getting to land. So a lot happening in a relatively short amount of time. And you can see 92 meters, 17 centimeters. So again, in actuality, let's take a look here, 15 million years. But even on a scaled up time scale like this, it's still only, maybe half a meter worth of space. So we'll continue. And this is our supercontinent Pangaea forming. December 10th, so a little bit out, 93 meters, 91 centimeters. So Pangaea is actually going to be the final supercontinent before the world sort of starts to take the shape that we know of today. And we'll talk about that a little bit more on when that event comes back up. But as we move forward, we'll see our third mass extinction, the end Permian extinction. And sorry, I guess I should say the little numbers here that you'll see on the other ones as well. So 95% is saying like 95% of the organisms that we're talking about here were wiped out. So like this extinction removed 95% of these organisms. So just something to think about. We do kind of go through these mass extinctions where it is sort of just a part of life, so where most of life dies off, I guess, in one way or another. But you can see December 12th, 94 meters, 57 centimeters. And again, just to put it in perspective, I'm still 250 million years ago, which is crazy to think about. As I'm coming into the last 5% of my calendar, I'm still talking about hundreds of millions of years ago. But we'll move up here. And so after that mass extinction and life kind of goes through its boom bust cycle, we start to see our early mammals and dinosaurs actually start to take place. At the same time as our end-Triassic extinction, about the same time, is the fourth event that I want to highlight and bring an analogy to is the supercontinent Pangaea breaking up. So, for me, how I like to explain it is, simply put, it's just the way the cookie crumbles. The countries that we know of now, and the continents that we know of now, and all their borders, is a result of Pangaea breaking up. Pangaea was our last supercontinent, and so, in the sense, the way the cookie crumbles, it was sort of just up to chance as Pangaea started to break up, what continents formed what, how big they were, a lot of their geological factors, and where they ended up on Earth was sort of just happenstance, similar to the way a cookie crumbles. Alrighty, so coming down here, this is December 22nd. We're now at 96 meters and 17 centimeters. Again, still 130 million years ago. But we started to see our earliest flowering plants, so we start to see life really start to bloom, pun intended, on land. And we don't just have, like large trees or ferns coming from the first seeds. We actually have plants and things that are flowering and blooming and producing fruit of the flower. And we'll continue down. And we actually have a little bit of a gap here, about 2 meters. And we're going to reach our second to last extinction, which is the end of the Cretaceous period. December 26th, so we're in the final week of the cosmic calendar now, still 66 million years. And right behind that one, we actually start to see our earliest primates. So humanity, or at least the remnants of it, the beginnings of it, 98 meters, 70 centimeters. So out of this 100 meter cosmic calendar, humans didn't really start to show up, or at least our ancestors, the beginnings of humanity, until the last meter and a third of the calendar, which kind of shows just how small or how young humanity is, especially when earlier when I was comparing it with the dinosaurs. The dinosaurs had 20 million years. And that was a lot longer than humanity, and even then it was really not much on the grand scale. But like I said, so less than a meter and a third on the final cosmic calendar. Alrighty, and as we move forward, so after the earliest primates, our next event is actually the Grand Canyon forming, which I thought was pretty cool. This is December 31st, so we're really squeezing it out now. 99 meters, 87 centimeters, so almost the last 10 centimeters of our 100 meter cosmic calendar. But something else you'll start to see that I've included is, because we're on December 31st now, I felt like it was a little bit of extra context if I also included the time of the day for the calendar. So we're December 31st, 12:34 p.m. So on the last day of the cosmic calendar, halfway through it, is when the Grand Canyon forms. And if you looked at 6 million years ago, I actually didn't know the Grand Canyon was 6 million years old. If you had asked me on like a play pause it question, I probably would have said like something that shows my ignorance, like 400,000 or something like that. But moving on, we start to see our first hominids, and this is 99 meters, 89 centimeters, so really inching it out again. Now we're at 2:05 p.m., so about an hour and a half. The hominids were like the first primates where you're walking on two legs and your brain is relatively large compared to your body. So you kind of start to see like humanity, like what makes us human, start to take place. And hold on. So then next we see modern Homo sapiens, which is like our skull starts to change, our jaw becomes a little bit smaller. Again, December 31st, but now we're at 11:43 p.m. So literally the last 17 minutes of the cosmic calendar in a whole year. And now I've started to include millimeters here because we're getting that small. So you can see 99 meters, 96 centimeters, but 7.4 millimeters, because that's the scale we're talking about. Even though I scaled this to 100 meters, the timeline is so grand that at the end I'm still here pinching pennies on millimeters and the time of the day. Alrighty, and this event will help us answer the 6th of the 9 question, and which is how many minutes before midnight on the final day did modern humans emerge? So as you can see, I put 11:43 p.m. here. So the last 17 minutes. So modern humans on the 100-meter cosmic calendar have only been around for 17 minutes, and if you look at the distance here, you can see a little under 4 centimeters. So I guess 3 centimeters and 3.5 millimeters is the distance left in the cosmic calendar when modern humans emerge. And that's going to lead us into the next question, number 7, which is how many minutes later did humans nearly go extinct? And if we're looking at the sign here, I put 11:51. You might not be able to see this, but I'll kind of pull it back. 11:51. So that's, I believe, 8 minutes. This is 11:43. Yeah, that's 8 minutes. So nearly 8 minutes later, we emerge. 8 minutes later, we go extinct, almost. And if we look at the distance here, I think we've only passed I guess I can't really see. What is that? Like 1 centimeter, like 1.5 centimeters. And as you can see, the remaining distance is very small. Really, the only other event we have is the ancient Greek astronomers, but in conclusion, 8 minutes later, we almost went extinct. And so just after that, we have our last extinction period, which is actually humans nearly going extinct. Again, December 31st, 11:51 p.m., 99, and a bunch of change. So what we believe would have caused this is essentially the end of the Ice Age, or the beginning of an Ice Age, where there's basically a huge drought, food scarcity, just not enough resource to support our population. And so I believe we only had a few 10,000 or maybe 100,000 humans after this extinction event left that started to regrow the modern population. But that will lead us here to our final event on the cosmic calendar, which I think is kind of funny. It's the ancient Greek astronomers. And as you can see, this is 11:59 p.m. So the last minute, I actually didn't include it here, but I think it's like 11:59 p.m. and 46 seconds. So like literally the last 15 seconds of the calendar of, entire Earth's history. But this is the one I want to expand upon for my fifth one. Just off the rip, I think it's kind of funny that we call them ancient Greek astronomers. Like, they're ancient, but yet on the grand scheme of Earth's history, this is actually the youngest. And quite simply, not really old whatsoever. This is like an infant, like a newborn infant compared to everything else that's happened on Earth. But we call them the ancient Greek astronomers, which is funny. But it kind of shows, like, that's why we're making this timeline, is because, humans, we don't really do a great job of comprehending things of such tremendous scale. To where, 2,000 years ago, to me, that's ancient. And to the Earth, that's literally not even a minute of its existence. But how I like to kind of explain this as an analogy is, if you really think about it, if the humans were formed on Earth and part of just like the natural process and the way of things, if you think about it, humans are essentially a part of Earth. We are the Earth observing itself. Like, we literally formed from the Earth, and then we look at the Earth, comprehend, understand, and observe it. So I kind of explain it like, it's like if you have a Ring camera set up on your home, and you like walk up to your front door, and then you pull out your phone and look at yourself through the Ring camera. It's essentially what we're doing. We're observing the Earth, which is essentially what we came from and what we're made of. So we're essentially observing ourselves. But that's how I kind of like to put that as an analogy. But that's the last event. So we'll go back through and we'll answer some more in-depth questions here in a second, but we'll pan one more time just so you can sort of see all the way down there, 100 meters. But this is the cosmic calendar in its whole. And again, we do this just because the time scale is so grand that simply saying million years ago, billion years ago doesn't really paint the picture or do a good job of helping, a random student on the street sort of understand just how much time is passing between these events we're talking about. So now that we've concluded the cosmic calendar, we're going to come back and answer these last two questions. Number 8 of 9 is it's giving us a scenario. Scientists have discovered this planet that is 1 astronomical unit from the star that it's orbiting, and we're saying that it's 1 billion years old. And if life were to evolve on that planet in the same manner it did Earth, what would we see? So, how to answer this is we're going to go back to the first 1 billion years of Earth's lifespan. So this is my marker for 1 billion years here. And we're going to see all of the events concerning the emergence of life in this first 1 billion years. And if you look at the cosmic calendar here, I have it color-coded. Pink is my life event. So if you look, this is the only life event that happens in Earth's first 1 billion years. If you want to just pan out real quick just at the start, just to show that this is the only pink event here that I have in the first 1 billion years. And what it is the earliest evidence of life. And so those earliest forms of life would have just really been simple microbes and nothing more, really. So for the final question, it's giving us the same scenario, but whoopsies, it's actually 3 billion years old instead of 1. So we're going to use the same methodology. If life is evolving in the same manner as it does on Earth, and the planet is 3 billion years old, I'm going to look at the first 3 billion years of Earth and see where we ended up with life. So here's 3 billion years, and we're going to come back, and it's actually quite a bit. We're all the way up here. So the most recent development of life in those first 3 billion years is actually just the first eukaryotes. So again, still single-celled organisms, nothing major, relatively. But yeah, on that planet, if it was similar to Earth and it's 3 billion years old and it's following the same trajectory, it's gonna have eukaryotes. If we come all the way back down, we'll see that the next life event doesn't actually happen until after the first 3 billion years. So something like multicellular life, which again was like, the simple sponges, that's not all the way until up here. And so that's past the first 3 billion years. So we would have single-celled organisms, and we would be approaching but not have reached multicellular life just yet.